Well, believe it or not, we made it to the last section of Math 3A, finding the average of a function. So let's start off simple. Suppose that this is not calculus. Suppose that this is pre-algebra. Find the average of the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can just add them up and then divide by 11. That's 11 numbers because they're counting to 0. So if you add them up and divide by 11, what's it going to be? 0 plus 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10. And then divide that by 11 because there's 11 numbers. The average is 5. And in math we use x with a bar over it to say average. So the average is 5. All right, now for example number 2. How about if you have the function f of x is just equal to x? And then let's integrate that function from 0 to 10. And then multiply by 1 over the length of that interval that goes from 0 to 10. So what's this going to be? So this would be 1/10 of, find the antiderivative, so that's going to be x squared over 2. Evaluate that from 0 to 10. So that's 1/10. This is going to be 10 squared divided by 2, so that's 50. And then 0 is going to contribute nothing. So the final answer is, what's 50 divided by 10? It equals 5. What a strange coincidence. 5 showed up as both answers. That's because these are the same exact problem. This is the pre-algebra way to do it. Add up the numbers and divide by 11, you get the average is 5. And here's the calculus way to do it. So for the average of a function, you go ahead and integrate that function over some interval, like from 0 to 10. Divide by the length of the interval, and you'll get the average. Slightly different way to look at this calculus way of doing it. The interval goes from 0 to 10. The function is just y equals x, which is a line with a slope of 1. And when you integrate, you're actually finding the area under the curve. So we were actually finding this area, and that area turns out to be 50. Because the base is 10, the height would also be 10 since it's y equals x. And the area for a triangle is 1/2 the base times the height. So that means that the area is 50. And then this has a length of 10. And so you take the area of 50, you divide by 10, and you'll get the average value of the function. Or in other words, the average y value. Then for example number 3, or maybe I should just go ahead and write that down. The average of a function f of x over an interval from a to b. So you find the length of the interval, that's going to be b minus a, and we're going to be dividing by that. And then you integrate the function from a to b. Multiply those two, and that's the average. And it's actually finding the average y value, because right here, these are the y values, so it's finding the average y value. So for example number 3, how about if you have the function x squared, and then we look at the interval from 0 to 4. So of course we could do this formula, but just to get a better understanding of what it's doing, if you look at a little table of values, so we'll just go by ones. So square each number. There's the squares. Then if you add up these and divide by 1, 2, 3, 4, 5, that would be an approximation for the average y value. And I say approximation because when it says the interval from 0 to 4, that means all numbers. So not just 0 and 1, but even 0.1, 0.2, 0.3, 0.4, etc. All the numbers in here. So this list is actually supposed to be infinitely long. That would take us a long time, so I'm not going to do that. So the average y value could be approximated by just adding up the numbers 0, 1, 4, 9, 16, and dividing by 1, 2, 3, 4, 5 numbers. So the average y value is approximately, this would be 20, this would be 30, so it's going to be approximately 30 divided by 5. It's going to be approximately 6. Now let's see what the average y value actually is. So integrate from 0 to 4, multiply by 1 divided by the length of the interval, and we're integrating x squared. So that's going to be 1/4 of x cubed over 3, evaluated from 0 to 4. So that's 1/4 of 4 gets cubed over 3, and then minus 0. So when you divide this 4 into that, it's going to leave 4 squared, or 16. So it's 16 thirds. (16 thirds) is actually 5.333. So our estimation wasn't bad, but we only used 5 numbers, so it was okay. The actual average, 5.333. Okay, then on to another example. You know, before I leave this one, something just occurred to me. So 5.333 is the average y value, which would be placed right about in here. So when is it that the function actually equals its average value? So when does the function equal its average value? So for example, if on average I weigh 143 pounds, well, it's not every day that I weigh 143 pounds. Sometimes a little more, sometimes a little less. Then exactly when do I weigh my average? That's sort of what I'm doing right there. So then we just need to take the square root. 2.309. So if I would have done all the numbers in here, eventually I would have done 2.309, and then the average y value would have showed up. Okay, that's enough with that one. Then on to the last example. So this would be example number 4. So for a ball that's thrown into the air, the velocity is equal to negative 32t plus 100. So this is if the initial velocity was 100 feet per second. So this is in feet per second. Then for part A, find the average velocity. Over the first 2 seconds. So like I said, this 100 comes from if somebody threw the ball with an initial velocity of 100 feet per second. Well, over the first 2 seconds, it's not going to slow down that much. So I would think that the average would be, I don't know, around 70 or 80. Well, let's see. So the first 2 seconds means goes from 0 to 2. And then divide by the length of that interval. And then integrate negative 32t plus 100. And this needs to be dt. So it'll be a half times. So this is going to become t squared over 2. And when you have over 2, the 32 is going to get divided by 2. It's going to become negative 16. T squared plus 100t. That gets evaluated from 0 to 2. So negative 16 and then 2 squared plus 100 times 2. And thank goodness for the 0, because that'll be 0 and that'll be 0. So how much is this? So we've got a 1/2 in front, and then negative 16 times 4 plus 200. It's 68. So the average velocity is 68, and this would be in feet per second. Then for part B, we're going to do the same thing, but over the total flight of the baseball. So that was number 4, part B. Find the average velocity What's the average velocity over the whole flight of the baseball? So the baseball would start at some height. I don't know what the height is because I wasn't given that part. And then it's going to go up, and of course gravity is going to bring it back down. And so then what we need to do is find out, when does it hit the ground? Well, when it hits the ground, the velocity is equal to 0. So for one thing, we need to take that velocity function, negative 32t plus 100, and set it equal to 0. So that would be 32t is equal to 100, or t is 100 divided by 32. So it's going to take 3 1/8 seconds until it hits the ground. So t is equal to 3.125 seconds. So this is going to be 0 seconds, and then when velocity equals 0, that's going to be t equals 3.125 seconds. So then integrate, the length of this interval would be this minus this, and then we're going to divide by that. And then integrate from 0 to 3.125. With respect to t. So again, this one is going to become negative 16t squared plus 100t. And then that gets evaluated from 0 to 3.125. And it's still going to be multiplied with 1 over the 3.125. Now keep in mind also, when you have velocity and you integrate it, then you're actually getting the distance function. I'm just saying that because I'm thinking I know what the answer is going to be, but let's find out. So negative 16 and then 3.125 gets squared plus 100 times 3.125. So inside the parentheses, we've got a negative 16 times 3.125 gets squared plus 100 times 3.125, and it equals 156.25. And then that still needs to be divided by 3.125. Divided by 3.125. And what I was hoping would happen actually happened. So the average velocity is 50 feet per second. Like I said at the beginning, this 100 is the initial velocity. And so if it starts off with 100, well, it's got to go up, which is positive velocity, and it's got to go down. And the average, 50 feet per second. And that's it. We're now done with section 6.5 and done with Math 3A.